This episode is another twofer, meaning that the CompTIA PenTest Plus training series as well as the offensive pentesting training series are going to inherit this video. And I think it's going to be like that for the next set of videos, however many that we're going to end up doing under pentesting, because so many of these tools are cross-compatible with both of those training series, and I'm going to be recommending that both sets of people, the people that are studying for CompTIA PenTest Plus practical exercises, as well as the people who are studying for the offensive pentesting pathway inside of TryHackMe, I think that both sets of people can actually get a lot of value from this series of content that's rolling out in the next few weeks, mainly because of the fact that, again, we're just going to be using the same sets of tools for both sets of instructionals and in practical exercises. So all of that being said, what we're going to be doing today is attacking a Linux machine. In the last video that we did on this series, we attacked a Windows machine, and in this one we're going to be attacking a Linux machine, and it's going to be falling under the Kenobi name tag, which is what the room is named under. And I don't understand the Obi-Wan Kenobi reference, so I'm not exactly sure why it was named the way that it is, but it's called Kenobi. That's the room that we're going to be going through, and it's something that we're doing to attack Linux. And so here's what it is. So we have, the walkthrough on exploiting a Linux machine. We're going to enumerate Samba for shares, manipulate a vulnerable version of the ProFtpd, and escalate your privileges with path variable manipulation. So it's a pretty solid series of exercises that we're going to do. It's not very long as far as the list of tasks that are concerned. Usually it's a much longer list of tasks, but we only have 4. So we have deploying the machine itself, enumerating Samba for shares, gaining initial access with ProFtpd, and then privilege escalation with path variable manipulation. And that's pretty much it. Those are all of the tasks that are assigned to us for this specific room. But in these tasks, we're going to end up doing a series of various exercises that are hopefully going to kind of help you flex your muscles a little bit and get more familiar with and comfortable with using tools like Nmap and the SMB shares or FTP or whatever it is, just so you can gain a foothold on a target machine and then escalate your privileges and then take an action towards whatever your objectives are at the end of it. So that is the outline for the video that we're going to be going over today, and I hope you're as excited about it as I am. And a quick little note from Hackaholics Anonymous, and we'll dive deep into it. To get the PenTest Plus notes, practice questions, and to join a supportive community of like-minded people like you, consider joining the Hackaholics Anonymous membership community. We have 4 tiers: the supporter, the agent, the guardian, and the master. And each tier gets their own Discord server and early access to content. The agent, guardian, and master levels will get exclusive content like line-by-line code explanations for how to create cybersecurity and PenTest Plus scripts, like exclusive downloads that they will get. For example, the notes document for this PenTest Plus and everything that I'm using for the lectures, as well as all of the practice questions and everything else that will go along that will be made for the scripts and everything else that we're going to be doing for the PenTest Plus training series. There will be free pre-made monthly Python automations that have to do with system administration, cybersecurity defense, as well as, of course, PenTest Plus and ethical hacking. And then there's going to be monthly live streams with me every single month, plus so many other things that you would get as a part of being a member of Hackaholics Anonymous in these tiers. To join, you can simply click the link in the description below, or you can go to our homepage and click the join button there. Or you can go to youtube.com/@hankhackshackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us continue with PenTest Plus. Okay, so here we go. I mean, again, Darth Vader, I don't understand the reference. I'm hoping that at some point as we go through this, I'm going to understand what the reference of Star Wars and these characters are, but for now I'm kind of lost with these references, so hopefully it'll make sense. And if it never makes sense to me, but somehow along the way you understand what these references are, please let me know, because I am stumped right now. Okay, but this guy, if you don't know who this guy is, this is Darth Vader, and then this guy right here is Obi-Wan Kenobi. Okay, all right, so here we go. This room will cover accessing a Samba share manipulating vulnerable version of ProFtpd to gain initial access and escalate the privileges with an SUID binary. We talked about SUID binaries in the junior pen tester pathway, and there's this place called GTFO, so get the fuck out bins. I apologize for the cursing, but that's literally what this sounds like to me. It's like GTFO bins, so binaries, right? And so these lists of binaries, and you can see the one that is kind of saved for me is the SUID filter. So you can go up here and really choose any of the other filters. You can choose sudo, you can do SUID, you can do shell. But these variations, or these categories, I should say, they will take all of the binary lists that are here, and they will show you all of the ones that actually have some kind of SUID element to it, so that if you find an SUID vulnerability or unpatched version of a process or a system or something like that that actually has the SUIDs attached to it, or if you want to take that attack vector. So let's say you want to look for binaries that have the SUID permission set on it, and then you want to try and manipulate those binaries to elevate your privileges to root user, right? That could be one of the things that so there are a few different ways that you can do it, right? So let's say that you're looking for something that has a file reading capability, and you want to manipulate that to elevate your privileges. Let's say you're looking at Python. Python is like a really big one because it falls under so many different categories. Or PHP, same thing. A very big one, falls under a lot of different categories. So all of these binaries are all with the intention of elevating your privileges, escalating your privileges, and making you a root user. And it just depends on what vulnerability you found inside of that machine that allows you to take advantage of it, and then you go ahead and get elevated privileges. That's literally the entire purpose of this website and this list of websites that is available to us. And you know what? I'm going to also star this because I think it's really important. This browser that I have is my hacking browser. So all of the things that you see right here over here are all essentially relevant to the stuff that I use. So DarkSec was one of the cool websites that we talked about in the last episode of this, that it shows you, it has labs available, right? So these are actual virtual machines, like the virtual machine for the blue room in TryHackMe, the one that we did previously where we hacked the Windows machine. There is this OVA downloadable that you can actually download the virtual machine itself that you can go ahead and hack. And it's really, really cool. It's like, I love the fact that this guy did this, and a big shout out to the creator of this room, or the creator of this website, I should say. This guy really did some like really, really cool things. And security engineer, administrator, and content director for TryHackMe. And his name is John. Oh, there we go. That's it. I think that's John. I think John is the one who created this whole thing. So big shout out to John. We appreciate this guy for doing that work for us. But anyways, so I kind of digressed and I went a little bit all over the place. But it was more just so you understand where these types of binaries can be found, or these attack vectors can be found, that if you want to escalate your privileges to root, you can actually go on that GTFO bins website, and from there you can try to find some kind of attack vector through which you can escalate your privileges and make yourself a root user. So that is available to you. So now it says make sure you're connected to the network and deploy the machine. What they're referencing here is the OpenVPN connection, but I'm going to use the attack box that's already on my browser, and I've already deployed the virtual machine, which is this button right here, and then I already have the IP address for that. And so now I'm super zoomed in, so I need to go ahead and view this in full screen, because this is going to look ridiculous if I'm still zoomed in like this. So we have that, and so this is going to be our attack box, and then with the attack box we can go ahead and run nmap basically to see how many ports are open on this IP address. And so the version of the nmap command that you run is totally up to you. I usually just go with ss just to make it a little bit quicker, and it requires that you have a sudo permission or root permission because it's a stealth scan for nmap. So when you log in inside of TryHackMe with the attack box, you always get dropped in as the root user. So you don't have to do sudo nmap ss. But if you're using it as a non-sudo user, or non-root, I should say. If you're doing it as a non-root user, but your user has sudo permissions, then you would run sudo nmap and then the rest of it. So that's basically what we're doing, and we're going to run that, and I'm just going to do -v for verbosity, and you can always do that as well, just so you get some more details onto the screen. And I'm not going to really kind of define a port range. I'm just going to run it as it is, just so we can see how many ports show up as open for us. And so we're just going to let this run for a couple of seconds, and we'll come back to it. Okay, so here's an interesting output. You can learn a lot from the outputs that Nmap gives you. So when we run something like this, and then we get nothing, right? So we got nothing returned to us. And it said all 1,000 scan ports on this IP address are filtered, meaning they're sitting behind a firewall, which prevents us from running a stealth scan on it. So you can always run a variety of different types of scans. So we can actually just do 10.201 and the IP address, right? We can basically do that just by itself, and then I'll still do verbose. And in the hint, they said do very verbose, like triple V, which is very, very verbose. So we'll do that and just let it run. And this thing right here, still, right? It still says the report for this, the host is down, received no response. So did I use the wrong IP address? 10.201.117.55, right? Isn't that the IP address? So let's see over here. 10.201.117.55. That's what it should be, and it is not giving us any kind of a response. So this is very interesting. So now we need to try to find other ways to get the answer to this, because this is host seems down. If it's really up but blocking your ping probes, try PN. So let's try that option, and let's see if we can get past it, because that is really interesting that it's not. Or actually, you know what, we can even do this, right? So let's see if the host is actually up. So let's ping it, and let's see if we're going to get some kind of a response. And if it doesn't respond, that means that it's either down or it doesn't respond to ping, right? So I'm pinging it and I'm getting no response. Usually by this time we would get multiple responses. So it says destination host unreachable. So that means that either it's down or it's not replying to pings. So another way that we can go ahead and check this out is to see if this particular website or machine is accessible through a browser. So let's go ahead and try to search for it that way. Let's see if we can actually find this IP address that we had previously through the browser and see where we can, or whether or not we can get access to it, because it's actually really interesting that it's not pulling up like this, and they didn't give us any kind of information around it. So I'm just curious as to why this is not loading. And so it says 10.201.117.55 again is not accessible, it's not loading. So one thing that I can do here is I could just restart it. I could just terminate the machine and restart it, because it shouldn't be this complicated. That's the piece that I'm actually interested in, because they give us instructions as we go through this. They literally give us all the instructions. And when they give us instructions like this, it leads me to believe that the room itself is not supposed to be overly complicated. And if we go up here, usually there's also like a difficulty level at the very top as well. And so in either case, this is not supposed to be as complicated as it is. So I'm just going to go ahead and terminate the machine, and I'm going to restart the machine so that we can try it one more time with a new IP address, and hopefully it'll work. And if it doesn't work, then we're whatever, but I think it should work. So let's see. Okay, here we go. We got a new IP address. Let's go ahead and try it again with the new IP address. And let's see if we get anything this time around. It's just so odd. There you go. Okay, so maybe it was an issue with the previous machine that was up. So now we actually get to see that there were 993 closed ports, and it scanned 1,000. So you just subtract 993 from 1,000, which means we have 7 that are on this list. So 1, 2, 3, 4, 5, 6, 7. 7 ports are open, and we have the FTP service, SSH, HTTP, RPC by NetBIOS, Microsoft DS, and NFS. So the network file share, and then you have several other very basic ones, and HTTP being that it's accessible via the web browser through the internet. We have secure shell that's open. We have the file transfer protocol that's open. So, okay, these are useful. So we have 7 ports that are open. Excellent. So I can kind of zoom back in here a little bit and make this easier for you. Okay, so now we've done our first scan with Nmap. We know that we have 7 ports open. So now we need to go ahead and enumerate Samba. Samba is the standard Windows interoperability suite of programs for Linux and Unix. It allows end users to access and use files, printers, and other commonly shared resources on a company's intranet or internet. And it's often referred to as a network file system. Okay, so it's basically the name of the brand. Consider it like that. So it's like the name of the brand for this functionality, which is the network file system, the network file share that you can do. So we saw that we have a port open here, right? So we have the 2049 port that has NFS on it. So that could potentially be the port that we're going to target for this scan, right? So essentially what it does is that it allows you to access and use files, printers, and other commonly shared resources on a company's website or on a company's infrastructure, we can even say. So anything that would be shared, okay? So think about it like that. So Samba is based on the common client-server protocol of server message block, also known as SMB, and we did an attack against the SMB server on the last video when we were attacking the Windows machine. SMB is developed only for Windows without Samba. Other platforms would be isolated from Windows machines, even if they were part of the same network. So this is why it's important for us to have access to Samba, because SMB, the server message block, is only for Windows. And without Samba, any other computer that's on that same network would not be able to access the files that the Windows machines access, or vice versa, right? So this is why Samba is actually so important. Now, using Nmap, we can enumerate a machine for SMB shares, and it has the ability to run and automate a wide variety of networking tasks, and there is a script to enumerate shares. So this is what's really handy about Nmap. So if you're studying for CompTIA PenTest Plus, or if you just want to get good at pen testing in general, you should be fully aware of the fact that Nmap has a bunch of scripts that come pre-installed with it. Now, there are ways that we can actually try to find out how many scripts or what kind of scripts are installed with our version of Nmap. So what we can do is, usually there's a location. So if I do ls, I want to say it's user share. Let's see. So inside of user share, do we actually have Nmap in here? And if we do, we can go inside of the Nmap folder to try to see what scripts there are. So we do. So there's the Nmap folder. So now we can do the same thing. We can do user share, and then we can do Nmap. And then inside of it, there should be a location called scripts. There it is. And so now we can do scripts. So now you're doing an ls. You're listing basically everything inside of the scripts folder of Nmap. And now you have this full list of scripts, right, that are available with the installation of Nmap that I have access to right now. So these are a lot of scripts. There's a lot of stuff that these things can, I mean, so many, honestly. Look, there's just an entire series of scripts just for SMB, right? So really, 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 really freaking useful tool. And this is why, like, Nmap is just such a favored tool when it comes down to doing reconnaissance and doing enumeration and all these things, because it even has access to its own set of scripts. And then you can even do a vulnerability scan for there we go. I think it's vulners, NSE maybe. Anyways, but yes, there are very many scripts, and you can always go ahead and just Google, HTTP vulnerability. It's going to scan for this vulnerability with the CVE ID right here. It'll scan for that to see if that's available. And there's just so many of them. So I can technically even do this. I can do the ls, right? And then I can pipe the output of this command, and I can try to grep for anything that has vuln in it. So if I do vuln, and you got to do the asterisk as well. So you got to do vuln on the front end of it, you need to do an asterisk. Just go, it knows to or maybe that's not how you do it. Hold on, let me see. I'm sure that there's a way that I can do this, because there needs to be a way that we can go ahead and find all the scripts that have the vuln in it. There you go. Okay, so you don't even need to do the asterisks. So as long as you just search for vuln, it'll show you all the ones that actually have vuln in it, meaning that these are scanning for vulnerabilities. So if we go ahead and we're trying to do a vulnerability scan for VMware paths or any of these HTTP CVEs or a MySQL vulnerability or a remote desktop vulnerability, a Samba vulnerability, that might be useful to us, SMB2 vulnerability, etc., etc. So all of these things are relevant to scanning for vulnerabilities. And then there's just the one at the very end right here, which is vulners.nsc. So all of these things are useful. And there's just so many different ways. So if you know that you're scanning for, or if you need to find a script for, let's say, SMB, right? So if I do that, now it shows me all of the SMB scripts that are available. And it could be anything from brute forcing to enumerating groups to finding OS direct discoveries, etc. Right? So very, very, very handy little series of tools. Now you can also get more information about all of these individual scripts to see, what they do or who created them, etc. One of the basic ways that you can actually do that is we can do nmap and then do -- script and then -help. And then after this, you can either give it the name of an individual script, or you can just type all, and it's gonna take a minute or a few seconds, I guess. But then it lists all of these scripts and the help information for it. So basically the manual kind of information for it, right? So there's a lot of scripts, obviously, so it's going to take much longer for us to do that. So let's say I wanted to get the SMB information for enumerating users. So let's say that's the one that I'm interested in. So I will copy this, and then I will just go ahead and do script help. And instead of doing script help all, I'll just paste that specific script and press enter. And it gives me the information about that specific script, the description of what it does and how to run it, etc. So nmap script help will get you information about each individual script, and then you can list all of the scripts as you just saw from where we're looking at. And this is just one of the very cool functionalities of nmap. So we already saw that there was smb enum shares.nsc and then smb enum users.nsc. So that's going to be one of the ones that we're going to end up using, and it's on port 445 because we already established that port 445 was the port that was running the server message block on our target, which is this IP address right here. So I'm just going to copy this. I usually go ahead and type it all out, but for the interest of time and so I don't have to go back and forth, I really do like typing it though. Honestly, I'm going to actually type it. You know what? I want to type it because I just like typing it, and it gets it in the cells of my body. You know what I mean? It gets it in my system. So I'm going to open this, and I'm going to drag it off screen into my second monitor so I can go ahead and look at it and be able to type it all out individually. And look, it shrunk my screen because the freaking thing, let's see. Look at that. Do you recognize who that is? Does anybody recognize who that was? That man right there with the thing right here. Who's that? If you know, you know. But I mean, if you know, drop it in the comments, because that's a really cool wallpaper. Like, you can't say that is not a cool one. Even if you don't know who that is, you just know that that's a very epic dude right there. Okay, all right, cool. Let me stop nerding out. I mean, you already know I'm a nerd. You shouldn't be surprised that I'm a nerd, because I'm a pretty big nerd, bro. You should be very, very familiar with who that is. If you are here, there's a very good chance that you also know who that character was. Okay, all right. So here is the command. This is what we're going to end up doing here to try to enumerate for our shares as well as the user. So let's see what we got. All right, there we go. So we are going to enumerate for the shares themselves, like the actual path to the shares, as well as the users that could potentially access those shares. So we got, port 445, Microsoft DS. Do we have any users that came out of this? Doesn't seem to be any users, so it's just one location, the port 445 Microsoft DS. So let's see what the question is. It says it has two ports, 445 and 139. 445 is later versions, 139 is the original one. Using Nmap, we can enumerate, okay, etc. There's a script to enumerate. Okay, great. So how many shares have been found? I'm going to say 1. Okay, so the answer is not 1, which means that there should be another one. So we could have actually just kind of sped up our own process and done this, right? So instead of doing that against only port 445, what we could have also done is we could have just, if I would have read it a little bit more closely before running it, I could have done both of the ports. And then now we can see that both of the ports are open and they actually both have the shares, right? So let's do 2. Is that also not correct? 2 is also not correct. So it says using the command, how many shares have been found? So I think maybe that's the incorrect answer that I'm trying to even look for. I'm looking for the ports themselves is what it seems like I'm looking for. And I'm supposed to be looking for the shares. So I think that's the key piece here, is that we don't get, or I'm going to read this a little bit closer, but I think we're supposed to be finding the actual path of the shares instead of just how many ports are open. So let's see what I can do here to solve for this issue. Okay, so here is what we have learned. The issue. So I tried this in multiple different ways. Okay, so the first few times that I ran it, it kept giving me the same issue. And then in the error message, right, it says unable to open the resolve configuration. So try using system DNS or specify valid servers with the DNS servers. And so I just did system DNS. And the next time that I ran it, it didn't give me that error message, but it still wouldn't give me the enumeration for the network shares, those SMB shares. So, tried doing another script called the SMB OS discovery to see if there's anything else that maybe it brings up for me. And then I did it again with the system DNS portion and still nothing. So finally, I moved on to SMB client, which is actually one of the tools that they tell us to use right after this question anyways. So what happens here is that the one that they want us to do is SMB client and then the actual path and then the weird little share name, which is actually here. It actually shows it to us, the anonymous share name, and then we have the printer and then we have the IPC as well. So this is the printer drivers and the IPC service. So these things you can actually find by using the SMB client and then using the -L option to list whatever would be available on this specific IP address. So this was not inside of the instructions that we got because for whatever reason, the script for enumerating shares was not working inside of Nmap, which is a really good thing to see actually, because there will be a lot of times where one given approach that has worked for you previously may not necessarily work for you again. So if that's the case, then you want to go and try to do a contingency plan. You want to go to plan B and then plan C and try a variety of different approaches to actually get the same result that you're looking for. So in this particular case, I used SMB client with the -L option, and I just gave it the IP address. And by the way, if you notice that the IP address is different, it's because I also tried restarting the virtual machine and generating a new machine just in case, I don't know, there was some kind of a connection issue or something. So I did all of that. And the -N option is to just to use a null session, basically meaning that it doesn't require a password to authenticate for us to be able to access this. So that's pretty much it. I think it would have probably even worked if we didn't do the -N option. So let's try it. And no, it does ask for a password. So definitely you want to use the -N option so it doesn't prompt you for a password and it'll still try to enumerate those shares. So the name of the share that we're looking for is anonymous in this case, but the number of shares would be 3 shares. So it says how many shares have been found. 3 would be the answer. And now it says, now we actually go and use the one of the shares. So inspecting one of those shares using SMB client. So in this case, connect to the machine network share. So SMB client using that location. And now it says enter Ben's password. So it's going to ask us for Ben's password. And in this case, I don't know if we have Ben's password. That's the other piece where I'm like, okay, well, why are you asking me to enter a password when I don't even have a password? So it says using the machine connect to the machine network share and the entering of the Ben's password. But I don't have Ben's password unless I'm missing something. So I need to go ahead and try to find Ben's password. Nope, it doesn't exist here. And usually something else can happen. So if we do this, so let's zoom out a little bit more. So if I go ahead and open up split view, sometimes there's an option right here. There's this little I button, the I inside of the circle. So if I click on that, it gives me information about the room that I'm in. But this is giving me information about the actual attack box itself. It's not giving me information about the virtual machine that I've logged on as. And again, when I click on the information for the virtual machine, still nothing. So there is no password for Ben. So I am curious as to why we're being told to use it without the password login. So here's what we're going to do. We're going to just try what they said, and we're going to try to use the SMB client to access that share without a password. And if it still tells us to access or to enter a password, then I will enter a password, I guess. Let's see. So password, I'm going to press enter. Oh, I didn't even need to press enter, or I didn't need a password. I just pressed enter. So now it says get a list of possible commands. So let's do help to get a list of possible commands. And so we have, what do we have here? Anything that might be relevant or useful to us. dir, which is to list directories, or ls to list directories. Make a directory. What else is here? So let's do ls just to see what's up. So inside of this location, there's a log.txt file, and I think that's the answer for the next one. So it says once you're connected, list the files in the share. What's the file that you can see? And that is the log.txt. All right. You can recursively download the SMB share to submit the username and password as nothing and open the file on the share. There's a few interesting things found. Information generated for Kenobi when generating an SSH key for the user. Information about the ProFtpd server. What port is FTP running on? That we already saw because we ran it. But let's see if we can actually read this by just doing a cat of this location. So we can't do cat. So what can I do here to be able to get this file or to be able to read this file that's on here? So let me see if there's anything useful to me. I think I can use the get command to actually download the file itself. So if I do get log.txt, getting file, etc., average 3 kilobytes. So let me see if I open up a terminal again, if it'll actually have the log.txt file. It does. Look at that. So it actually worked. So the get command actually got the log for us. So now I can do it on my machine using cat. And now we can see that we have a bunch of information inside of this log.txt file. Now the question that they're asking is what port is FTP on? And I mean, usually it's on 21. So that should be fine. So let's see what information inside of these. This is a very large file. So let's see what else I can find. I'm going to go through it. Oh, here we go. Port 21 is the standard FTP port. So port 21, there you go. That's pretty much it. So open the file on the share. There's a few interesting things. Information generated when SSH key for the user, and then information about the ProFtpd server. So it's running on 21. And the generated information for generating an SSH key for the user, that might be interesting. So your earlier Nmap port scan will have shown port 111 running the specific RPC bind. There's just a server, or this is just a server that converts remote procedure call number into universal addresses. When an RPC service is started, it tells RPC bind the address at which it is listening and the RPC program number it is prepared to serve. In our case,
Port 111 is access to a network file system. Let's use nmap to enumerate this. So nmap p111 script nfs ls. I really hope that this actually works because the other one didn't work. So I'm just going to copy this one just in case I don't know, messed up the command that I ran or something. I don't know, you know. So I'm just going to copy and paste it exactly as it was. We're going to press enter. Okay, this one actually worked. This one seems to have gotten us some more interesting information here. So this is the port 111, and then these are the various permissions that are attached to these different locations here. And so we also have the show mount that has the var log here, and then the stat nfs that also has the var location here. So this seems to be fairly useful. So /var, however you want to pronounce it, that seems to be the location, the volume, right, that has these things mounted on it. So it says what mount can we see, and the mount itself is the var, the var log. Okay, cool. So now we need to use ProFtpd to be able to gain our initial foothold, our initial access to this server. ProFtpd is an open source FTP server, and it's compatible with Unix and Windows systems. It's also been vulnerable in the past software versions. So let's get the version of it to see if we can actually do anything with it. So one of the cool tools that are available to us for this is Netcat, and we can use this to connect to the machine on the FTP port. And what happens when you run it is that it actually gives you the version of whatever it is that you're trying to connect to in the header of it. So if I do Netcat, and then what's the IP address real quick? It's the 10.201.36.0. If I do that, I need to give it the port number as well. So what was it? We did nmap, and then we do 10.201.36.0. Oh my gosh, I'm making silly mistakes right now. Okay, here we go. So FTP, or port 21, dude, duh. Okay, good Lord, honestly. So there we go, port 21. And so there it is. You see, like right in the header, it says 1.3.5 server. There we go. ProFtpd 1.3.5 server, default installation, etc. So that's basically all we needed right there. So, okay, so it's 1.3.5. That's the version of it. Now it says we can use searchsploit to find exploits for a particular software version. And it's basically just a command line version for exploitdatabase.com. If you've never been to exploitdatabase.com, this is a gold mine of resources that, I mean, there are so many things that you can find here. So this is the website, right? And so this is where you land on when you come here, and it has the exploit database. And then at the bottom right here, there's also the Google hacking database that actually shows you a lot of advanced search queries that you can type into Google. I'm not going to get distracted by that because I always get distracted by that, but I've referenced it so many times in a variety of different videos on this channel, and I'm sure we'll do it again at some point, but I just want to stay on task right now. So if we go over here and if we do ProFtpd, right, then we have all of these. It just pops up. There's all this stuff. And so there's the 1.3.5, 1.3.7, and then more versions of 1.3.5. So we could probably just narrow it down to 1.3.5. So if I go ahead and do that, there we go. These are the ones that show up here. Now we can also do the same thing for the command line version of this tool or of this website, which is searchsploit. And you can essentially just run that command. The command itself is searchsploit ProFtpd and then do the version. So if we just go over here, you'll see, and we should see the same result, right? So searchsploit, which is the command line version, ProFtpd, and then 1.3.5. There you go. And then there we go. So we get 4 results here. And then if we go to the website, we also have 4 results here, right? So pretty useful, pretty handy little tool in case for whatever reason, let's say you don't have access to a web browser to be able to go to their website, you can still access their database of exploits by going to your command line and finding it. And then these would be the paths to be able to find the actual thing itself, the actual exploit itself. So Linux remote 3762RB. So if we go here and we go and try to do the, I think it's this one. So the first one, I'm just going to click on it. And if we go to that, it should say, nope, that's not the one. So I think it's actually, this is probably the path on the machine that may have access to it. So let's see if we can do ls or find maybe. Let's do find for Linux remote 37262RB like that. Oh my gosh. Okay, good Lord. Let me stop that. I forgot to do a, holy cow. That's a lot, dude. That can't be it. That seems like a lot. I'm also going to do the to the dev null folder. So no, it's still a lot. Wow. I did not realize that I would get that many results from that. That is insanity. So maybe that's not it. Maybe it's not what we're looking for, or maybe it's not on the local machine or something, because that seems like an insane amount of results for something that should just give me one result. That's gnarly. Okay. But anyways, so this is the mod copy command execution, which is, what do we have? Mod copy command execution. So that's the one right here. And it is up here. So we do see it says exploits 37262. So that part is right. But the / Linux element of it, that's the part where I thought maybe it was on the local machine or something. But anyways. Okay, so what does it say? It says how many exploits are there? So we have 4 exploits, and we should have found an exploit from ProFtpd's mod copy module, which we did, right? So if we actually want to go view it here, we have the mod copy all here. So, and we have the remote command execution through Metasploit, and remote command execution again. So there's 3 mod copies. One of them has not been verified. 2 of them have actually been verified and served useful. So the mod copy module implements site cpfr and site cpto commands, which can be used to copy files or directories from one place to another on the server. Any unauthenticated client can leverage these commands to copy files from any part of the file system to a chosen destination. So this is why we call this a vulnerability, and this is why we want to find out what version of the server we're using and what potential vulnerabilities exist. So it's a very simple line of thought, right? So first you do an enumeration to see what services are running on the target IP address. We find out that FTP is running. Okay, let's see what version of what service is running on FTP. So we did netcat to see what it was, and it said it was ProFtpd, and then it gave us the version 1.35. Okay, great. So now let's go and try to find any exploits or anything that might exist for that version of ProFtpd. And we did, and there were 4. And then from that one, from those 4, there was the mod copy module that implements these commands, which can be used to copy files and directories from one place to another. Any unauthenticated client can leverage these commands to copy files without authentication, right? That's the piece right there. You don't need a username and password. So there we go. So now we know that the FTP service is running as the Kenobi user from the file on the share, and an SSH key is generated for that user. So I did not read through the file on the share. So I should definitely do that. So what we're going to do on this terminal, we're going to do the cat, and then we're going to grep for Kenobi, like that, right? Is that how you spell it? Okay, there we go. So it says enter the file in which to save the key, and the key is saved in Kenobi IDRSA. Create a directory for that. Your identification has been saved in home Kenobi SSH IDRSA. Your public key has been saved in idrsa.pub. And then this is the SHA-256 password for the Kenobi at Kenobi. The user is Kenobi, and the group is Kenobi, and their path is home Kenobi share. So interesting information. There we go. We found all of that information. I didn't read through it, but you normally, when you find a file like that inside of a share, you do want to read through it so you can see that there is the Kenobi user that's inside of it. So, I was lazy and I didn't sit here and read through that massive freaking log file. But you should, in a real exercise, you should be sifting and sorting through a bunch of information. So one of the things could be, you know, for example, if we wanted to do the same thing, we wanted to cat through it, and instead of, since we don't know who the user is, right, we may go ahead and do a search for identification, for example. And I search for that, and now it says your identification has been saved in home Kenobi, and it was like, oh, okay, so maybe that is the user. Okay, there's another thing that we could potentially search for that would give us more information, and it could be something like public key. That could be something else too. So we get that. Now it says your identification has been saved in this location, and then, or excuse me, your public key has been saved in that location. So, okay, so there we go. Now we also know what the user is, and we know that they do have a public key that's also available here. So there are a few different ways that you can actually read through a massive log file without reading through it line by line and grepping for certain pieces of information. For example, the person's identification, right? Their ID, right? So that could be something that would be handy to you. There could be another way that you can do it where you can just say, okay, grep for user. Maybe it's not identification, but when you grep for user, obviously a bunch of information, like a lot more information will come up. So add a single anonymous login, it assumes that you have the user group, set the user and group under whatever user group, map bad user. What else can we do here? Is there anything in here that would give us the name of the user? Because it was supposed to show us the username, right? Because we saw user is Kenobi, right? And the group is Kenobi. So that was supposed to be in there somewhere, but for whatever reason, it's not showing that to us now in this output. So I'm kind of a little bit skeptical about that. But anyways, so this is kind of how you would go ahead and find various types of information that would potentially give you the name of the user. So now we have the name of the user. So the FTP service is running. The user itself is Kenobi. And now there's an SSH key that is generated for that user. So we know all of these things. So what we need to do now is we need to copy that information, right? We need to get access to that information. So if we do netcat and then give it the IP address again, and then now we're trying to connect on port 21, but this time around we can potentially actually log in, or we can potentially copy, right? So copy file, copy the key, right? You could technically do all of that stuff because we now know, where is it? We now know, let me run the previous command again. So we're going to go to Kenobi. We now know that Kenobi's home directory is this. We know that there is a key that was saved inside of the SSH ID RSA. So that's where it's actually been saved. And then the public key itself has been saved as idrsa.pub. So we know that. So that this is the actual file itself that we want to download, right? So now we've discovered that information, and you can see that right here. So they've copied the file home Kenobi SSH IDRSA. So they copied that entire directory. And then from there, they also copied the var temp IDRSA file as well from a very different location. So we have the mounted location, which is what we found earlier. You see, you see how these things kind of stack on top of each other, right? So when we went to enumerate for the shares, and we saw that there was this location, right? So in this, on that port, when we ran this final command, we saw that the mount itself was the var location. And then from that location, we can potentially go ahead and rummage around a little bit. So if I actually go to this one, which is the one that we were initially logged in on our on the connection. So NC, there we go. And not NC, excuse me. It wasn't NC. It was the SMB share. That's the one that we were supposed to use. So SMB client, there we go. Anonymous, there we go. Press enter. And now we're in here. Now I can do ls. And it says this. And I don't know if there you go. That's the current directory, is that location. So let's see what we do if we went up one, and if I printed it now, I'm still in the, okay, so that's not going to work. So what if I just did CD and then I did actual path itself? Would that work? Nope, it does not. Okay, so I'm trying to remember which one was the one where we found all of the information. I think, oh, so it was on this port. There we go. So it's on port 111, and I'm just logged into that share, so that's not the one that I was looking for. So we did the nmap on port 111. This is where we found the mount, which is the volume right here. And then from that mount, we also found a bunch of different locations or a bunch of different things that were in it. And so if we go further down here, or right here, where is it? In here, we see that there's the var temp and an ID RSA. So if we went over here, and sorry if I'm going like back and forth a lot, I'm just trying to kind of find these different elements for us to be able to connect the dots here. So inside of the var location, we have backups, cache, crash, local, lock, snap, www. It doesn't show me anything for temp. The NFS show mount is var right here, and then we have another var right here. So potentially it would have been inside of this this file, the log file. So maybe we can go ahead and read through the log file and look for the var entity and see what we can find. So we can see that the log file is that, and then there's the samba.log as well, and then var library samba, spool samba library. Okay, so still I don't exactly know where they found this temp ID RSA inside of that var location. So that's the piece that I would assume that this is like the default location that would be the temporary storage for that ID RSA file. I'll just give it that, and that'll kind of be how we would deduce and conclude that that's how they found it. But in either case, so we know that the var directory was a mount that we should see, which was on that task. So we've now moved Kenobi's private key to the temp. Oh, that's what it is. Oh my gosh. See, I need to read more instructions. I feel so stupid right now. Good Lord. Okay, so this one copied it, and then this one transferred it to the temporary location. I feel so silly. I can't believe I did that. Okay. All right. So now we've moved Kenobi's private key to the location. Okay, so what I need to do is I need to connect to the FTP server, and from there I'm going to do site CPFR and transfer that into my location. So let's see, it literally says it on the screen, ready for destination name. I feel ridiculous right now. That's just, oh, good Lord. Okay, whatever. All right. We learn from our mistakes, ideally. So, okay, there we go. There's that. So we have connected. Now we need to do site CPFR and then home Kenobi SSH ID RSA, which is right on the right-hand side of the screen. So I'm going to kind of stay zoomed out so I can actually see the path right here. So we're going to do site, right? CPFR. That's what it said, right? Site CPFR, yep. And then we're going to do the home Kenobi and then give it the .ssh ID RSA like that. So now it says file or directory exists and it's ready for destination name. So now I need to do site CPTO and then put it into that temp folder. So site CPTO and then do var tmp and then ID RSA, right? Yep, ID RSA like that. Copy successful. Excellent. Okay, great. So we did it. Nice. So now we need to mount that temp directory to our machine. So let's see how they did this over here. While inside of our downloads folder, right, Ben at cloud, which I'm guessing, I don't know if it's the root location that they're talking about. I think this is the person logging in on their via OpenVPN. And so this is their own machine that they're doing this. So they made a directory called Kenobi NFS, and then they mounted that mount right there, that var location to that Kenobi NFS, and it says only root can do that. So they did it with sudo. So they ran it, and now when they go into that directory, so if they do lsla and look at that, they should be able to see everything that was mounted from the external location, from that other location, from this mount right here. They should be able to see it on their local computer, right? So this is actually the mount that they created on their local computer. So we have a network mount, and now we can go to that and get the private key and then log into Kenobi's account. So they took the key, right, and they changed the permissions on it so that they can access it, and now they were able to access it using ID RSA, and the Kenobi user flag would be available on that. So let's go ahead and do those pieces ourselves as well. I'm going to refer to my second monitor so that I can go ahead and type all of these things out without going back and forth. So the very first thing that we did was we copied the ID RSA file to the temporary location on the var directory, and then from there we now need to go ahead and create a mount on our location here. So I'm going to close this out, and I'm going to go ahead and create a mount. So let me see where I am. I am here. So I'll also go into my downloads folder just to be similar to what they did. So we're going to do sudo make directory, and then we're going to create a mount Kenobi NFS, basically exactly what they did. So I'm going to create a directory here, unable to resolve host, etc. name or service not known. That's silly. Why is the name or service not known? So let me do a make directory. That's so weird. Why would that not be? What do you mean? So it file already exists. Where is it if it already exists? Oh, I put it on the, oh, I feel so silly. So what if I go to MNT? That's where it is. So I thought I made it inside of my downloads location because I thought that's what they did, but we actually made it on the root location. That's why. So if we go to the root, we see that there is a mount location already, and so that's very silly. You see, these are basics about Linux that I've created freaking multiple Linux courses, and like sometimes I even forget. I'm like, oh my god. Hi. What if I wanted to create it in my current location? I would have had to do this. I would have had to do make directory and do a dot and then do the /MNT, and then it would have made it in my current directory, but I didn't do that, and I just did /MNT, so obviously it created it inside of the MNT location. Okay, so let's just go into Kenobi NFS. There should be nothing in here. Okay, great. So now, since we've already done this, what we can do is we can run the mount command. So it's going to be mount, and then we need to give it the IP address of our destination. So I'm just going to go ahead and get that IP address real quick, which is this guy. And it's this, what we're doing is we're mounting this IP address, and then we got to do the :/var. We have to do that. And then now we're going to do just the MNT Kenobi NFS. And so there we go, that's the mount. And now if I do ls in this location, okay, it's not doing it. So that's an issue. Maybe I should have done sudo mount, maybe. And let's see if that would have worked. But let me run this one more time. And let's see if the sudo mount command itself would work. So sudo mount 10.201.36.0 var mnt Kenobi NFS. Unable to resolve, name or service is not known. 201.36.0. Why is this not working, buddy? Now I'm concerned that I did something incorrectly. Okay, let me troubleshoot. Okay, so it's quite odd. So the LSLA would not work while I was in that location, but I just transferred myself to my downloads folder and I ran LSLA one more time. Even though when I ran sudo mount again, it still gave me that unable to resolve BS. However, now when I do the LSLA from the downloads location, it actually gives me the contents of my mount, which is kind of odd, but whatever. So, okay, that worked. So now that we have done that and we're inside of, we can see the contents of the mount folder, the next thing that we want to do is we want to move the contents that is that temporary folder ID RSA, right? So we want to go ahead and copy it to our current location, so inside of our downloads location. So we're just going to do copy, and then we're going to do the /mount mnt Kenobi NFS /tmp /ID RSA, and then we got to do this dot at the very end so that it actually copies it in our current folder, which is the downloads folder. So now if I do an ls, we should see what the ID RSA is right there. Perfect. So that actually worked. Okay, great. Now we just, the rest of it is very basic. So we're going to give it the permissions of being able to, what is it? I think it's read and write, if I got that correctly, and an ID RSA. And so service name unknown, that's very annoying. That's so annoying that that's not working. Yeah, read and write is what we gave to it. That's so annoying that that's not working, but, or it's giving me that error message. It's not that it's not working, it's just giving me that error message, and that's what's like most annoying out of this whole thing. Okay, so there we go. So now we're going to do Kenobi at the IP address, which is this thing right here. And we're using that ID RSA file to log in. So if this works, we would be logged in as Kenobi. And we accept the fingerprint, and there we go. We are officially logged in as Kenobi. So hopefully that made sense. I'm sorry if I made it a little bit confusing for you, but essentially what we did was we followed the directions exactly as far as, you know, creating a mount location, which is this mount Kenobi NFS at this at the root. So it's root, which is that initial / MNT Kenobi NFS. This is our directory that we created. And then we ran the mount command, so sudo mount, and then we gave it the location from the target machine / you got to make sure you have this colon at the end as well. So colon / var. And then we mounted it to this folder that we created. And now we have all these things inside the folder. And we know that we copied from this location, right? So we copied that log file, or not the log file, excuse me, that key file. We copied that key file that was for Kenobi. We copied it from the share location into our location when we did our netcat connection, and we were able to go ahead and copy that file into our temporary folder. We did all of that. So that worked great. And then all we did after the fact was we just used SSH to remote login into that. And then when you do SSH-I and you give it that key for the ID RSA, it doesn't ask you for a password for this user. So it just used that key to log us in as that user. I apologize if it was confusing. I hope it was not too confusing. I hope if you replay what just happened, you can kind of make sense of what I did. And I apologize if it was confusing. Sometimes I go back and forth and I make some mistakes. So hopefully that made sense to you. So now it says, what is Kenobi's user flag, which would be inside of their location. So print working directory, which is home Kenobi, and it's that user.txt file. That's what we're looking for. And so there's the user flag. That's the answer to the final question here. So we did all of that stuff, and there's the user flag. Awesome. All right, we made it work. We figured it out. I am so sorry if that was confusing. I realize that sometimes I go back and forth, and it can be confusing, but hopefully you were able to keep up and make sense. Okay, so cool. Let's now go to the privilege escalation with the path variable manipulation. In order to be able to manipulate these variables, these path variables, we need to first understand what SUID, SGID, and sticky bits are. So when you look at the permissions of any given file, so if we go inside of this location, and so we have these two locations, right? So we have the file itself, and then we have the actual folder. So if I do lsla, it'll give me these permissions. So you see these permissions right here. And they're all assigned to each individual one, whether it's a hidden directory, which is what we see right here. Anything that has a dot in front of it is hidden. And then whether it's something that is visible, like the share or the user text file. So whatever it is, you can see that it has its own set of permissions. So for example, the bash history has all of the permissions set, right? So let's understand what this actually means. So we have the read write, and then we have the next dash next to it, which would be the X technically. And then we have another read write, and then that would be an X, and then read write, and then that would be an X. So this one, if it's an S, right? So in this case, read write S, capital S, read write capital S, read write capital T, these would be considered the SUIDs, SGIDs, or the sticky bits. So an SUID bit on files, user executes the file with the permissions of the file owner. So let's go look at this now. So we have the file owner in this case, or that's kind of the current directory. So let's look at this file right here. So that's the file, the user.txt file. The file owner is Kenobi and the group is Kenobi. Okay. So if we execute that file, we would execute it with the permissions of the file owner, which is these three, this first chunk right here. The very first item tells us whether or not it's a file or if it's a directory. So if it's a D, it's a directory, right? If it's just a dash, that means it's a file. And then the next three items are the permissions of the user. The next three items are the permissions of the group. And then the last three items are the permissions of everybody else who's not either the user or the group that belongs to, meaning any other user, right? So they can only have read permissions for this file right here, okay? So the user executes the file, meaning anybody other than the creator of that file, right? So the user executes the file with the permissions of the file owner, which is in this case, Kenobi. The SGID bit is that the user executes the file with the permissions of the group owner, which is again in this case Kenobi. The file that's created in this directory gets the same group owner. So this is the S user and then the S group. And then the sticky bit has no meaning, but the users who are prevented from deleting files from other users. So it says on files, this is what would happen. On directories, this is what would happen. And in this case, for the sticky bit, users are prevented from deleting files from other users. So that's basically it. So here's what we need to kind of take away from this, okay? So if we have the bash history, for example, the bash history, the user who created it was root, and the group that owns it is the root group, right? So if we execute this, or if we try to access that, we would be getting the permissions of the user who created it. But interestingly enough, all of that history just goes into the dev null folder, which from what I understand just deletes everything. So if I try to get into the bash history location, and it says there's nothing, it's not anything in there. So it's not a directory, I'm sorry. So if we try to do a read out of it, and it's empty because everything from that history is being sent into this dev null location, which immediately deletes everything that's transferred into it, okay? So that's what we got as far as the user who owns it, and then the group that it belongs to, and the permissions for those elements. So now that we kind of understand this a little bit, we can try to take advantage of this. So an SUID bit can be dangerous because some binaries like password need to be run with elevated privileges as it is resetting your password on the system. However, other custom files that have the SUID bit, what other custom files could that have the SUID bit can lead to all sorts of issues. That's a weird sentence. So some binaries such as password need to be run with elevated privileges. However, other custom files, this I think is an extra word, other custom files that have SUID bit can lead to all sorts of issues. Okay, that's an extra word. That was a very confusing sentence. To search a system, see, another misspelling here, another typo. So to search a system or to search the system, for these types of files, we can run a find command where we're looking for the permission where the user has the S set, the SUID set. And the type would be a file that we're looking for. So you see the type right there. The type is a file that we're looking for, and all the error messages, because there's going to be a bunch of permission error messages. So I'm gonna run this for you without that last element so you can see what it looks like. So if I run it, you're going to see a bunch of permission denied messages, which then distorts and kind of just pollutes our results. And all we're trying to do is find the things that are actually useful to us. So we'll run it again, and then we'll do the 2 to the dev null, because we already know all of these permission denied errors now will just be deleted, and all we'll see is the actual results, right? So none of these have permission denied. So if we run it, now we can see this binary and this binary and all of these binaries right here have the user SUID set on it, which means that we can actually potentially manipulate these to increase our privileges to a root user. So now, what file looks particularly out of the ordinary is the question that we're looking for here. So we want what specific one. I usually use this as a hint, so it's looking for 3 different elements. So let's see. So I mean, upon review, this one seems to be kind of an issue right there. The sudo command, the change shell, I want to say, I think that's what that stands for. So those are interesting. Menu maybe, but I think sudo, or maybe even the change fn. But I want to say sudo. So user bin sudo is what I'm gonna do. Let's see if that's the one. It's not. So let's see, change fn. No. Change shell. No. Okay, so it said I'm going too fast and it blocked me out. So user bin, none of those things were an issue. So user bin new group, user bin at, sh menu maybe. Out of the ordinary. Those are the only ones that really seem out of the ordinary for me, unless I'm blind or something. Okay, let's see. The only other one that I can think of would be menu. Okay, there you go. I mean, ultimately, we got there by just trying all of the variations, but sudo seemed more dangerous to me than menu. But so the next one says run the binary, how many options appear, and when we run this binary, it just gives us these 3 options: status check, kernel version, ifconfig. So there is that. Now, strings is a command on Linux that looks for human readable strings in a binary. So for example, if you do curl on the local host, uname and these are the actual strings, my apologies. So this is a string that would be human readable, uname, ifconfig. These things are readable, right? So this shows us the binary that is running without a full path. For example, it's not using user bin curl. It's just saying curl, right? Or user bin uname, it's just saying uname. So as this file runs as the root privileges, we can manipulate our path to gain a root shell. So we can actually do this. We can echo the binary of shell, right, into the curl path, the variable path. So this is what gives us, okay, because the whole thing that we're talking about here is path variables, right? So a path variable is this. That's a path variable. That's a path variable. Which means what? Instead of having to actually use the command's path to be able to call on it, for example, user binary curl, instead of having to do that, they just call on curl. So that means that user binary curl has been added to the path variables, and we can just go ahead and run curl just by itself without calling on that full thing, right? So that's a really key element. So now we can do something like this, where we can actually echo the shell into curl, change the permissions of curl to all permissions allowed, and then export all of that information into the path variable. So everything that's stored inside of that, the path environment, right, the environment variables, all of that is inside of this temp folder. So we're going to export everything into the path variable. And now we can run user binary menu again, and ideally we should be able to pull something. So if we do status check, which is number 1, and it gives us that we have a root user's permission, the group ID would be Kenobi and all that stuff, but the root user would be, or our user permission would be root, right? So hopefully, again, that made sense, because we took the binary of the shell and we put it inside of the curl environment variable. We changed all of the permissions of the curl environment variable because that was something that we could actually modify. And then we transferred all of them into the full list of environment variables, which then allows us to run something like user binary menu to be able to access it. And then when we access it and run it, it will do it with the root permission, which is that user that owns it, right? The full permissions, that SUID permission. I want to make sure that I extend the timer on my machine because I don't want to get kicked out. So we're almost done, and I don't want to get kicked out in the last minute here. Well, it says 57 minutes, which is kind of silly. I think it's my secondary window that is still operating based on the old machine that I ran. So I think that's kind of the issue that it's having. So, okay, anyways, let's go ahead and now we're going to run the final set of instructions here so we can pull the root flag from the root location. So we already know that we have these 3 binaries. So the next thing that we need to do is we need to just run these commands that they showed us here. And hopefully that made sense. If it doesn't make sense, you can read into it a little bit more and find out more about these SUIDs. There was in the junior pen tester training series, there was a series of educational videos that had to do with increasing privilege by doing something like SUID manipulation. So you can learn more about them by going through those videos. But for now, we're just going to do exactly what they did. So they went to the temp folder. So we're going to be inside the temp folder. We have all of these things inside the temp folder. We're going to echo the binary shell, and we're going to send it to the curl command. And then we're going to change the permissions of the curl command to all of those to be able to read, write, and execute. And then we're going to export the path, right, into the temp folder, which is where we are. And we're going to give it all of the path variables, right? So that $sign represents all of the path variables. So we're taking everything from the path, all of the stuff that's stored in it, and we're putting it inside this temp location that we're in. And the temp location is accessible by everybody. So it should have access to all of the stuff that's inside of it, meaning Kenobi should get access to temp folder and be able to run everything with the permissions of the temp folder. So if we go back one, you should be able to see it. Oh, my computer. Don't freeze on me, buddy. Oh, no. I see. It was the attack box that was running out of time, not this virtual machine. So the attack box was running out of time, and now I have to redo all of those exercises to get back into the Kenobi user. That should be fun. So we're going to do all of that stuff again. Okay, let me do this real quick, and then we'll get back to that last piece. We were so close to finishing. All right, we'll do everything again, and then we'll get back to that last piece. Okay, so thankfully the attack box was the only thing that crashed, so I just needed to remount everything from this IP address. I'm just gonna add another hour to it. I should be done in the next 10 minutes, but I'm just paranoid now. But essentially the original virtual machine, the victim machine, was already up. So everything that we did on that machine is still applicable. So all I had to do was just come back into the attack box, create a new mount Kenobi FS directory, and then mount the actual var variable, or the var mount, excuse me, from the target machine to our machine, that mount that we created. And then when I do LSLA, we can see that everything's here again. So now what we can do is we can just go ahead and log in from that location. Or so basically what we can do is this. We would go ahead and copy the ID RSA file, right? So from Kenobi, we're going to copy the ID RSA to our current location, and we should be able to see it here. And there it is. So we're going to change that permission to ID RSA, and that should be available as well. And now I can go ahead and do ID RSA or use that ID RSA file to log into this location, which is my IP address, Kenobi, and there we go. Okay, perfect. So now we do have it, right? So now we're here, there's the text file, and so we were able to get the Kenobi flag already. So all of that is all good, and we were able to do all of these things. So now we can continue from where I lost my connection, which is finally getting that the menu, right? So the binary that we had found was that menu binary. So this thing right here, this piece right there, that's what we had originally found. So what we want to do, and hopefully I've already done it, but I'm just going to do it again. I think it died on me at I don't remember when it died. So hopefully I can just go ahead and rerun all of these things. And so I don't know if doing these things multiple times, if it's going to hurt me or not, but we're going to try it anyways and see if it'll work. So there we go. And then now user bin menu, and there's that. So if I do that status check, right, and do ID, there it goes. So it actually worked. So again, we took a shell, right? We just took the binary of the shell. For Kenobi, by the way, we took Kenobi's shell binary. Or actually, excuse me, this is the system binary. So the Kenobi binary would be add user, like this, user binary, and then shell. So we took the system binary and we put it into the curl command. And then we changed the permissions of that curl variable, not the curl command, it's the curl path variable, that environment variable, right? Because again, it would be user bin curl would be the full path for this. But instead of now curl holding user bin curl, that environment variable now holds the binary shell inside of it. So that environment variable now calls on the binary shell instead of calling on user bin curl. Okay, and then we went ahead and changed the permission of that binary variable to everything, that environment variable to everything. And then we exported all of those variables into our temp folder. And then from there, we just ran the command. So user bin menu, we just ran it. And now we can see that it worked, right? The menu itself came up, and then all I did was just call on a status check on it and pressed enter, and then I ran the ID just to see if my ID had actually changed, and it has changed. So if I do who am I, it says I'm root. Okay, so that's great. So now what we need to do is we need to find out where we are. So we're in the home Kenobi, so we need to go ahead and get into the root. There we go. And so inside of the root directory, we should have the root folder, which we do. There it is for the root user. So we're going to go into that folder, and there's the text file. So we're going to read that text file, and there's the root flag. All right, we figured it out. We made it. Even though I made some mistakes, we did make it finally in the end. So hopefully that was relatively simple enough. I hope you were able to make sense of it and you were able to follow along and actually get the results that I got. So if we go ahead and do a quick little review here just to see what we did inside of this entire series of exercises, so you can kind of hopefully I'll try to make it a little bit more simple from the review, right? So we deployed the machine, right? That's the very first thing that we did. And then we ran Nmap and it showed 7 ports open. The first time that I ran it, the machine itself that I deployed wasn't connecting. It wasn't giving me the things because, I don't know, for whatever reason, it was down. So I reran the machine. I restarted the machine. And then the second time that we ran it, it worked like a charm. So that was easy. Enumerating the Samba for shares, this was a piece that was kind of challenging because these scripts that were supposed to work for us through Nmap did not work. So the way that we did it was, instead of using that script, we actually used SMB client with the -L, right? And -L allowed us to pull all of the shares that were available, and we saw that there were 3 shares available. One of them was print, the other one was something else, and then there was anonymous, right? And so anonymous was the one that was of note, that seemed kind of fishy. So we're like, okay, so let's go ahead and inspect it. And when we ran it, we saw that we could just press enter and we can get into it, and there was no password that was required. And from there, we found that there was a file inside of that share, which was that log.txt file. And there was a lot of information inside of that log.txt file, including the port that their FTP was mounted on, as well as the user, right? So we searched for identification, we searched for custom key, something like that. And so we found that, okay, there was a home Kenobi. So we found out that there was a user named Kenobi inside of that location. So we're like, okay, great. So we know who the user is. We know what port they're running FTP on. So from there, we were able to go ahead and try to find. And so this SMB get anonymous, the username, and so you can recursively download the SMB share too. And this is actually something that I did not do. I just downloaded the log file itself. So open the file on the share. There's a few interesting things. This is not the command that I ran. once I was inside of the SMB client, when I pressed enter and it showed SMB, I just typed get and I downloaded the log file directly. So I didn't run this specific command, but you can always run that command to download everything that's inside of the anonymous folder, which would have been that log.txt file. There was literally only one thing that was in there. So I just ran get instead of SMB get, and then I just put get and then the name of the file, and it downloaded that file. So much simpler version of this. And then we read the file and we found the port number, and then we found that there was the Kenobi user. And then in our first Nmap scan, we also saw that port 111 was running, and it runs the RPC program. And in this particular case, the RPC program was doing an NFS, right? The network file system. It was a share that was being accessed. So we ran this command right here, which is the script for listing everything that's inside of the NFS service. And that one actually worked for us. And from there, we got the location of the mount, which was the /var. And then we went to try to attack and gain our initial foothold through the ProFtpd service. And so we knew that there was an FTP port that was open. We just didn't know what kind of server was running on that port. So we did netcat, we did nc, and then we give it the IP address of the victim machine as well as the port number, which was 21. And then in the header, it said this is running ProFtpd version 1.35. And then from there, we went and used the exploit database through searchsploit as well as the actual website itself. We saw there were 4 exploits that were running, and one of them was the mod copy module that was available, which allows us to copy something from a share and then transfer it to our own location. So we went and did that. So we did the copy of the share, and then which was specifically the Kenobi key. We took that Kenobi key and we transferred it to that VAR temporary location because that was the one that we could access. So we transferred it from one location to another location. And then from that, we created a mount on our local computer. So this is kind of where it gets a little bit technical. So while we are inside of that network share service, we transferred the key file from where it was sitting and we copied it into the VAR/temp folder because that was something that we could access on that network share. And so since we could access that on the network share, we were then able to go ahead and transfer that, not really transfer, but create a mount on our local computer. We created a folder. This is what we did. We created this folder on our local computer, and then we mounted that location. We mounted everything that was from that VAR location on the target machine. We mounted it on our local folder that we created. And then when we did that, we were able to run LSLA, which is basically listing everything, including all the hidden files and all of their permissions. And we saw that all of these things that came from that VAR path, from that location, it is now accessible through our local mount, which means that now we can access everything on our local mount as if we're doing it on that remote machine, which is perfect. So then what we did was we copied that temp IDRSA file. We copied it on our local, that dot that represents right there, that represents our, I'm kind of blocking it, sorry. We copied everything that was on here and we transferred it to this dot represents that current folder, which is that downloads folder. So we copied that IDRSA key to our local downloads, and then we changed the permission of that key so that we can actually use it. And then we were able to use it as an SSH password. Instead of doing a secure shell password for Kenobi, we went ahead and actually just used that RSA key instead of a password. And we were able to log in as the Kenobi user. Once we did that, we were able to get the Kenobi user text flag. And then we had to elevate our privileges. And we did that by leveraging SUIDs, which is that super user ID or the set user ID bit. And so we did a search for all of the files that actually have that user permission set. And we were able to find this one binary, which is that user binary menu, which allows us to interact with it using the permissions of that set user ID. And then from there, we ran it, right? And so it showed that there were 3 different options that were available, which is like, get status, etc. So something that was important in this specific tactic that we did was leveraging the path variable. And this is the part where I just want to make sure that I kind of explain it a little bit better. So the path variable, and it doesn't really give us that much of an explanation on this, but it's very important to understand. So we have a folder, right, on every machine. That is the path folder. Everything inside of that path folder has the full path of a binary. For example, user bin curl, right? This is the full path of the curl binary. So instead of us having to type out user bin curl, so for example, Python is another one of these things, that there's a Python full path of where Python was downloaded. And instead of doing that full path to where Python is, we just type in Python 3 or Python whatever. And now we can access that full path of where Python is installed. So instead of having to do that every single time, for convenience, there's this location called the path folder. And inside of that path folder, it has a bunch of these different paths, and each one of them points to a variable. So this is pointing to the curl variable. So instead of you having to type in the full path, you just type in curl, and it accesses that path. So what we do with this here is we change the path that's assigned to the curl variable to the path that's assigned to a shell, which is the system binaries shell. So when you see anything that has user bin, these are the binaries that belong to that user that you're logged in as, for example, Kenobi. But when we do the /bin shell, that's the system's binary. So we are assigning the system's binary for shell to this curl variable and replacing this path with the other path. And it expired, but I'm perfectly fine because we're already done. We're just doing a review. So we replaced the path to curl with the path to the system shell, and then we changed the permission of that variable, that curl variable, to read, write, execute for users, for groups, and for everybody else. And then we exported all of that. We exported all of those entries that are inside of that path variable. We exported it to the temp folder, basically saying that we want to update our list of path variables with this new variable that we just updated, right? So we want to make sure that we can, every time we run curl, we should be able to actually go ahead and run a shell, right? That's basically what we do when we do this export and we're updating our list, right? So when we did that, then we were able to run this user binary menu. And then when we did that, it ran the command, this user binary menu, it ran it with the root shell. And then from there, you just enter. You do a status check, you get into it, and now you're root. And then everything that you do from status check in this particular case is now being done with the ID of root. So if we would have escaped out of status check, if we would have escaped out of the menu and escaped out of status check, we wouldn't be able to get the root flag because it would turn us back into Kenobi. So we want to stay inside of that and run everything inside of that. And we were able to do it as a root user. And then we were able to actually go ahead and run the command. So here's their explanation. We copied the binary shell, called it curl, gave it the correct permissions, and then put its location in our path. This meant that when we use the user binary menu and when we ran it, it's using our path variable to find the curl binary, which is actually a version of user shell, as well as this file being run as root, it runs our shell as root, right? So that's like a much more concise version of what I just tried to explain. So when we did that, we were able to finally retrieve our root shell. If you would like to get more videos like this one, make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel, whether it's for CompTIA PenTest Plus, whether it's for offensive pen testing, or whether it's for the AI for cybersecurity training series, which is my current favorite training series that we're working on, which is the AI for CySec video right here. Super excited about that one. I'm very, very excited about it. It's one of the things that I have wanted to work towards for a very, very long time. So I'm happy that we're finally actually making that progress, and there's a lot of content that's being constantly uploaded into this channel, and it has currently, as it stands, it has to do with offensive security, pen testing, and it has to do with AI. Everything that I've done up until this point has been more for defensive security. For example, we have the SOC Level 1, SOC Level 2 security engineering. There's the Cybersecurity 101, CySec 101 playlist. So there's a lot of stuff that's available if you're just starting out and you want to learn more about the basics. And then there's a lot of stuff that's available for CompTIA basics types courses. For example, the playlist that we have for Linux Plus. So people have used this to pass their Linux examination. People have used it to land jobs that require Linux. For example, SpaceX. That's actually one of my favorite stories. So Linux Plus is a complete course. You can actually use that to either get masterful at Linux, or you can use it to prepare for your examination, etc. CompTIA PenTest Plus is the one that we're working on right now. This one has all of the lectures completed, so now it's more about just giving you a bunch of lab exercises that you can learn more about what you can do with the various tools. Network Plus is also completed, and this is one of those things that, again, you can use it for your certification exams or to just get really good at networking. Security Plus is for the foundations of security, and so all of these things are also available for you. I'm probably going to end up doing CYSA Plus as well, and I'll do a few other CompTIA courses that I think are really important and foundational. But for people who want to learn more about system administration, Linux Plus is great. Network Plus is great. All of those things are really good. If you want to go into security, there's the Security Plus, there's Cybersecurity 101, there's SOC Level 1, SOC Level 2, Security Engineering, all that. And then now we're currently inside of the pen test, which is offensive security, and of course, AI. So that stuff is super exciting for me. And there's all these things that are available for our Hackaholics Anonymous members that have to do with Python and teaching people how to script. There's a really good video that is a kind of like a beginner to intermediate video, which is the Python for cybersecurity video. And that video, if my keyboard actually starts working, that video teaches you how to use Python. So this is actually the one right here, how to build algorithms for cybersecurity in Python. So this is actually a really solid video. It's 6 hours and 17 minutes long. It's one of the more well-received videos that we've done, and a lot of people have loved it. So there's a lot of stuff. There's a lot of stuff that's available on this channel that you can leverage to teach yourself and to upskill yourself so that you can become more valuable in the market. So if you have any questions for me, please drop them in the comment section below. If you want to review what we talked about in this video today, if you have any questions about what we did today that were maybe not clear, please drop comments. I'm very responsive in the comment section. And of course, make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel. And then there's Hackaholics Anonymous. To get the PenTest Plus notes, practice questions, and to join a supportive community of like-minded people like you, consider joining the Hackaholics Anonymous membership community. We have 4 tiers: the supporter, the agent, the guardian, and the master. And each tier gets their own Discord server and early access to content. The agent, guardian, and master levels will get exclusive content like line-by-line code explanations for how to create cybersecurity and PenTest Plus scripts, like exclusive downloads that they will get. For example, the notes document for this PenTest Plus and everything that I'm using for the lectures, as well as all of the practice questions and everything else that will go along that will be made for the scripts and everything else that we're going to be doing for the PenTest Plus training series. There will be free pre-made monthly Python automations that have to do with system administration, cybersecurity defense, as well as, of course, PenTest Plus and ethical hacking. And then there's going to be monthly live streams with me every single month,
plus so many other things that you would get as a part of being a member of Hackaholics Anonymous in these tiers. To join, you can simply click the link in the description below, or you can go to our homepage and click the join button there. Or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. So boy, Hank Hackerson at Hank Hacks Hackers, your favorite network system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I will see you in the next video later.